Hi guys, today I'm going to cover OSPF concepts. I believe OSPF had a lot of theory boys, complexity and difficult to understand, right? And CCNA level, we also had some main concept to understand. Firstly, let's talk about version. Nowadays, OSPF had the two versions, version 2 and version 3. Version 2 support IPv4 and version 3 upgrade from version 2 support IPv4 and IPv6. About operation, in the high level OSPF operation can be divided into three phases. Phase 1 neighbor processing, phase 2 route calculation, and phase 3 is maintenance. Okay, let's go to the each phase. Neighbor relationships processing start right after physical backup and engineer release configuration. To become neighbor, routers use hello message to exchange some parameter, and they must match each other. For example, the hello include error ID, timer, router ID, authentication, error type, MTU, network type, IP connectivity. The router ID between router must different, cannot overlap, and another must match. If one parameter don't match, neighbor process cannot establish. Understand that the requirement is important not only for implementation but also for troubleshooting. Let me example. After I configure the OSPF on the two router, when I saw the OSF neighbor, I see they stuck in the star and exchange state. So if I understand the neighbor relationship condition, so I can guess interface of two router is a mismatch MTU because the neighbors are stuck in exchange and star. So I can check the MTU both of interface and save time, and then I can resolve and troubleshooting my problem easier. Okay. The next we talk about the neighbor state. A neighbor state shows the neighbor of router during the neighbor relationship processing, where the A state from down to the full. Down is the first state. In this state, router has been received hello message from remote router, but router cannot send hello message to remote router. And we had a temp state. This state only valid in the non-broadcast multi-asset network, so I would like to ignore it. Okay. We had the init state. In this state, router receive hello packet from its neighbor, but in the hello message doesn't contain its router ID. For example, router A receive the hello message from router B, and it check the hello message, but it doesn't see its router ID in this hello message. So they need move to the next step, two-way. In a two-way state, router will list the router ID of neighbor in hello message and send to the neighbor. The neighbor now see its router in ID, and then they can move to the next step. Like example, router A receives the message from router B, and it check the message and see, I see my router ID has in the message, so I can confirm our community can be two-way, so we can move to the next state. The next state is start state. In this state, router in the same subnet perform the DR, PDR, and DR author selection to determine which router will handle exchange database in next state. Next state, same like the name exchange state. Router with the DR role will handle the exchange the database decryptor. The database decryptor will change between the DR PDA to each DR author router. Database descriptor contain LSA header describe the content of link state database, not full LSA information. The full LSA information will exchange in the loading state based on the content of database descriptor, and after receive the full link state advertised, router must send the updates as acknowledgement to its neighbor. The last state is full. Router had fully agency with each other, and this state is success. In the case, we see the routers neighbors stuck in one of state except two-way or full. It means something wrong during the neighbor relationship process. So in this case, we need to come back to the neighbor relationship condition and check each condition per the device, and then find out the issue. Okay. We go to the DR and PDR selection. This happens as star and chain, and OSPF has some type of interface based on the interface setting called the OSPF network type. The DR and PDR election happen on the broadcast and non-broadcast network type. By default, in the Ethernet links, OSPF use network type is broadcast. So OSPF need elect router, one router on the subnet SS designated router or DR router. The DR router, designated router, handle the database exchange process, and then it need select the PDR, the backup of DR, and DR author. DR author is router neither a DR nor a PDR. Reason why the OSPF need DR and PDR, because the database exchange process on the Ethernet link doesn't happen between every pair of router on the same VLAN. So it use DR and DR author to exchange each database information, and make sure that on the author get a copy of each LSA. DR can send the packet to the on DR author router using the multicast IP address 224.0.5, and on router on DR router can send the packet to the DR router using the multicast address 224.0.6. Let's DR and PDR use the two roles. The role 1 user interface priority. High interface priority will win. In the case interface priority same, the router ID will be checked. Highest router ID will be DR, and the DR and PDR had non-program. Non-program it means in the case original DR down, the PDR will take care the DR role, right? And then the DR original DR recovery, it will be the DR author router, and the DR and PDR selection will not stack. So we call non-program. Neighbor stay between the DR and PDR router, we have the full state. DR author router, we have two-way state, and DR and PDR we have the full state. Sorry, it's the full state, not the two-way state. Just my typo. Sorry. This is the full state. Okay. Okay. So we go to the router ID. The router ID identify the router in OSPF domain. It change between the router and listed in the hello message. OSPF Router ID has 32 bits format and writing in the dotted decimal, same like the router IPv4, right? And in the OSPF domain, it's not unique. It means cannot overlap between the router and can be configured by the command router ID follow the ID value under the OSPF config mode. In this case, we don't use the manual value. The OSPF on the router will get the high IP address on the loopback interface. In the case router don't have a loopback interface, the OSPF will use the high IP address on active interface. The active interface is the interface up and has stay up. So the condition to all OSPF working it means router has one active active interface has IP, okay. And important, the router ID no need to be the routable. Reason why router ID include in the hello message, so it don't need the routing between the router to router. And OSPF router ID can be changed, but change the router ID call the reset neighbor and reestablish the agency. So best practice, we should keep the router ID stable and configure the router ID under the OSPF configuration mode using the command router ID. Okay, after the neighbor relationship processing complete and successfully, the OSPF using the SPF algorithm to calculate the best path, and the OSPF using metric to compare the route, and logic is lower is better. Actually, SPF algorithm is so complex. Alex with me, but there are some more we need to understand. Okay, about metric from source to destination in the OSPF has logic E. The summary of OSPF's interface code of on outgoing interface in the route from source to destination, and the code calculation had the formula code equal reference bandwidth divide interface bandwidth, whereas the reference bandwidth by default is 100 megabit per second. For example, I had subnet A and subnet B, and visually we had the two back, right? Back 1 go to router 2, router 4, and router 5. And second is router 3 and router 5. So go to subnet A to subnet B. We need to calculate the code of outgoing interface, right? This one, right? This one, and this one, and this one. So total is 50, right? And another part we have the code is 10, 100, and 10. So total code is 120, right? So the logic is lower is better. So the router 1 will choose the first part to go to router 2, router 4, and router 5. In this case, we go to from subnet B to subnet A. So we need to calculate the code of this box, this box, this box, and this box, right? The outgoing interface. And the code of interface can be set manually using the IP OSPF codes and follow the cost value under the interface mode. And the reference bandwidth can be changed using autocode reference bandwidth and follows bit under the global configuration modes. But we should be keep the reference bandwidth same on router. So we should we keep don't need change. We should not change the reference bandwidth. The next we will talk about area. This is important in OSPF. OSPF can be had config the single area or the multi area for the large networks. Area had the specific area, area 0, backbone area, and other must connect to the area. If the router belong to the one belong to the multi area we call the router is area border router, and we had the concept internal router. This is one router in the one area, but area not the area 0. We had the backbone internal router, one router in area 0. The reason why OSPF has the separate area helps increase the performance of routers, isolate the chain topology, and reduce custom bandwidth requires LSA. Okay, so LSA, OSPF use the link state database to exchange information and then build network topology. Link state database contains the LSA floating from router to router. So SDN process on router has same information. For example, I had the router 1. It's great LSA for itself and subnet 10.10.10/24 and float to the router 3. Router 3 float one more time to router 2. So router 2 and router 3 now have the own information of router 3. Router 2 also want to float to router 3, but before it add router 1, it had the LSA already or not. In case yes, it will not float the LSA, so this prevent LSA looping in OSPF. LSA will be refloat every 30 minutes, so router use this method to monitor topology and maintain the routing with its neighbor. Okay, we had LSA type. As a CCNA level, we can explore the 3 main LSA type: the 1, type 2, and type 3. LSA type 1 are called router LSA, decrypt one router, created by one router. Define the router ID, interface status, IP address, or subnet mark of interface. LSA type 2 sent by DR or PDR, decrypt a network that has the PDR and DR to exchange the information. LSA is advertised between the DR, PDR to the DR author router. And we had the final summary LSA layer 3 decrypts a subnet in the another area sent by area border router. Okay, the last one today we had the maintenance. After done the neighbor relationship process and route calculation, OSPF had the last task. The maintenance is monitor each neighbor use hello message using the hello interval and dead interval. Hello interval in broadcast network has value is 10 and dead interval has values 40. If router did not receive any hello message during the dead interval, it understands the remote router down and need to react and update the information to the another router. And if everything okay, a router also refloat every 30 minutes, same like I mentioned in previous. Make sure everything okay. Okay, I think today is enough and a lot of terrible, right? I believe must remember the workflow in the OSPF. The first one, enable processing. Router will install neighbor to the remote router using the parameter area ID, router ID, network type, authentication, so on. And all parameter must match between router and router ID cannot overlap. And in the broadcast network, the OSPF elects DR and PDR. DR router will handle the exchange the database decryptor, and DR to DR's neighbor state is full state. DR to DR author router is a two-way. So two-way is a normal state in OSPF. And then OSPFs using SPF algorithm to calculate the route and then input route into the routing table. It's the metric, and the metric is the summary of um, interface code of outgoing interface from source to destination, and logic is lower is better. And the code interface has the formulas, reference bandwidth, divide interface bandwidth, and reference bandwidth has default 100 megabytes per second. And we should keep the on reference bandwidth the same on the router in the networks. And after that, OSPF needs the maintenance check each router, monitor the state of network using the hello interval and that interval. Hello interval in broadcast network had value is 10, and that interval had 40 seconds. And LSA will reflop every 30 minutes to make sure everything is fine in the whole topology. Okay, thank you for watching, and hope get your like and subscribe my channel, friend. See you in the last video. Bye bye.